The article I reviewed was titled A Soft Total Artificial Heart, First Concept Evaluation on a Hybrid Mock Circulation. The primary scientist who worked on the research in this article is Wendelin Stark, a professor of functional materials engineering at the Swiss Science and Technology University. He previously earned his PhD at ETH Zurich in mechanical and process engineering. Stark worked alongside with one of his doctoral students named Nicholas Kors. Stark decided to work on developing artificial hearts for many reasons. Here are a few facts about cardiovascular disease. 30% of deaths in the world are due to cardiovascular diseases. Cardiovascular diseases affect over 26 million people worldwide. There is also a shortage of donor hearts available for transplants, which is why artificial hearts are needed. Current devices for heart failure treatment include VADs, ventricular assist devices, and TAHs, total artificial hearts. VADs are implantable mechanical pumps that support the heart. The LVAD, the left ventricular assist device, is more commonly needed, and treatment from LVADs has improved over the years. But patients are still experiencing negative effects, such as hemolysis, thrombosis, and infections. Many patients who receive LVADs end up having problems with the right ventricle as well. However, bioventricular BiVAD support is very limited. TAHs, total artificial hearts, are singular devices with two pumps, which varies from VADs. There have been many successes with TAHs. 1,400 TAHs have been implemented in patients. The 1-year survival rate is 60 to 70%, which is still less than VADs. However, TAHs are still underdeveloped. The largest risk of VADs and TAHs is thromboembolism, which can be fixed using anticoagulation therapy, which also poses many risks to patients. Stark's research is based on 3D printing an artificial heart. The artificial heart was first created by printing a lost wax casting of the outside shape of the heart. The mold was then filled with silicone and sat at room temperature for 24 hours. Lastly, mechanical heart valves were clamped to the inlets and outlets of the ventricles. The heart that Stark designed is a total artificial heart. However, the heart lacks an aorta, the pulmonary artery, and pulmonary and caval veins. As a replacement for the aorta, an expansion chamber, the EC, is placed between the left and right ventricles to allow the heart to pump. Here are 4 images of the general design of the STA. Image A is the outer shape. Image B is highlighting the chambers of the heart. Image C is the final form of the STA. And Image D shows the inside of the heart where the expansion chamber is located. Here is an image of the expansion chamber that is placed between the left and right ventricles in placement of the aorta. As air is pumped in, the chamber expands, and as air is released, the chamber contracts. Here is an image of the soft TAH, the STA, in a human circulatory system. As you may notice, there are pressurized air pumps that allow the heart to inhale and exhale caused by the expansion chamber. As for results, one of the misguided statements that the news article made about this peer-reviewed article is that Stark created an implantable TAH. This article is actually about how Stark created a new concept for an artificial heart that, with lots more research, can one day be used to create a 3D printed heart. Here are a few advantages to Stark's research. The heart that was 3D printed and the production of the heart through 3D printing are both simple processes. Additionally, the soft material, the silicone, that the heart is made of replicates the biomimetic motion of the human heart. Lastly, the designed TAH is also easily adaptable to accommodate patients with individual needs. Some downfalls of Stark's research include that the presented STA is too big to actually fit into a human, and there are still many political and regulatory issues that need to be fully considered before a 3D heart can be implanted. Stark's research in general is hopeful that one day scientists will be able to create 3D printed hearts.